Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. Today we are going to learn how to find a particular integral of type 2 in higher order differential equations. See, this type 2 means the right hand side of the differential equation is of trigonometric form, that is sin or cos x. What? Sin or cos x. Now this type 2, the particular integral is something little different from the other types. Students often get confused, but don't worry, let's make it super duper easy for you, and if you follow me step by step, everything will stick permanently in your brains. So no skipping, no distraction, just concentrate completely. Ready? So let's go. So let's understand in a very simple way how this method of particular integral of type 2 works. Okay, now type 2. Fine. See this type 2, here we have the function as f of d of y is equal to sin ax or cos ax. See carefully, it's what? Trigonometric form. So any question on which the right hand side is trigonometric form, sin or cos, it's always type number 2. Remember, only sin and cos. Okay. See, in the type 1, what's right? Right side was exponential form or sine hyperbolic form or cos hyperbolic form or a raised to x form or constant. If you haven't referred that video, that is also very, very important in solving differential equation, please find a link in the description below and refer that. Okay. Now here in type 2, f of dy is equal to sin a into x into cos sin x or cos x. That is type number 2. So the right side is what? Trigonometry. It means we can write here, see, f of dy is equal to sin x or cos x. So we can write the particular integral yp will be equal to sin ax or cos ax upon f of d, the differential function. This is type number 2. Now see, numerator is trigonometric form, sin x or cos x, but not only sin x or cos x, go to the basics, go to your trigonometric identities. In engineering, these are very, very important. So you may find it in the formula sheets, but better memorize them. Okay. So the family, the trigonometric family or the identities are, we have sin square x is equal to 1 minus cos 2x whole divided by 2. Cos square x is equal to 1 plus cos 2x whole divided by 2. Then we have sin a into cos of d is equal to half sin a plus b plus sin a minus b. Right. Then we have cos a into cos of b is equal to half cos of a plus b plus cos of a minus b. Okay. And lastly, we have one more, sin a into sin of b is equal to half cos of a minus b minus cos of a plus b. These are all the trigonometric identities to be remembered. That means the right hand side is either sin ax or cos ax or any of these types. We call it type number 2. Remember it. Okay. I am making everything crystal clear for you here. Okay. This method is a little complicated, but if you follow this, it will be very, very easy for you. So be attentive, listen carefully. So what is type number 2? Sin x or cos x upon f of d or any of these types is type number 2. If you get in the right side any of this, so use a formula and make it to sin or cos plus or minus form and do it. Fine. Now when you find it is type number 2, what you will do? Now you know you have a question. The right side is of this form of sin or cos x trigonometry. You know you found a CF. Now you know it is type number 2. Now you need to find the particular integral for this particular integral for this type number 2, and it's different. So understand here carefully. When you find its type number 2, what we do here? See, very important. replace in denominator, listen here, only d square by minus a square. See here the twist. Replace in denominator only d square. Listen carefully. What? Only d square. I am writing here. Only d square by minus a square. And I will again mention, don't touch the d's. Don't touch the d's. In the denominator, replace only d square by minus a square. Don't attempt to touch the d's. Okay. So, when you replace the denominator by minus a square, that means even if you have d cube, write it as d into d square. Only replace d square. In place of d square, put minus a square. Say, for example, sine 2x. What is that? 2. Replace d square by minus 4. Okay, again, see, many people do mistake here. Understand? What it tells us, d square by minus 4, so d will put minus 2. No, wrong. It's wrong totally. Don't do that. What I am telling, only d square, don't touch the d's. That's why I am mentioning, don't touch the d's. Replace only d square by minus a square. D keep as it is. Wherever there is d square, put minus a square. That's it. Okay. Now, so after replacing d square by minus a square, if the denominator is equal to 0, or we can also write f of minus a square is equal to 0, then what's the logic here? In the previous type also, we multiply the numerator by x, that is x into sine x, whatever given, or cos x, and differentiate the denominator. Getting it? Differentiate the when you multiply, when the denominator becomes 0, after what? Replacing d square by minus a square, then multiply the numerator by x and differentiate the denominator. Okay. Again replace d square, I write directly here, by minus, this means d square by minus a square. Wherever there is what? D square, replace with minus a square. Again, if f dash of minus a square equals to 0, again then multiply the numerator by x, here it will be x square into sine x or cos x, okay, upon differentiate the denominator. What is differentiate f dash d? It's f double dash of d. Again replace d square by what? Minus a square. Again replace d square by minus a square. Again the process keeps on continuing till all the d's are eliminated. That's it. You get a perfect solution for that. So, what's the concept here? Again I repeat here, watch carefully, listen, lend your ears to me. What I say is very, very important. When you listen to me with concentration, everything goes and settles here. You need not again worry about what to do in the problems. Okay. Now, when the right side is sine or cos, trigonometric, or any of these forms, type number 2. So, what is the process in type number 2? We only replace d square by minus a square. We don't touch the d's and all. After replacing, if denominator 0 becomes 0, then multiply numerator by x and differentiate denominator f dash. Again the same cycle repeat. Again repeat d square by minus a square. Again you check. Again if the denominator or f of what you replace minus a square is 0, then again I write denominator is equal to 0, or f dash of minus a square is 0. Then again multiply the numerator by x. It was x here, again x means x square, sine x or cos x upon double differentiate denominator. This process keeps on continuing till you get what? All these are eliminated. That means the solution of any differential equation is to remove all these. That's it. But one more thing we'll ask. See the basics. What if d is there? What if d remains? See, again I go back to the first class, I told you the basic, into d, that d comes in numerator means what? Differentiate. Into d square means double differentiate. Then upon d, if d comes down means what? integrate. That means in a solution you are getting sin 2x upon d. Then integrate. Integration sin 2x is minus cos 2x by 2. That's it. And one more thing to remember here, very important. If suppose if I am not getting d upon d, I am getting say d plus something. Say example, if I get this very important point here. Okay, say for example, if I get say example, I get 1 upon d plus 3 say. So I get something upon say d plus 3. Then what will do? I am not getting d, I am getting d plus something. In that case, what to do? Rationalize. What to do? Rationalize. That implies if I am getting what? 1 upon d plus 3. So 1 upon d plus 3. What is the rationalizing factor of d plus 3? It is d minus 3 whole divided by d minus 3. So that means the denominator something, we are getting it as say d minus 3. This is just an example, okay. Practically I am solving the problems upon d square minus 9. Again replace d square by what? Minus a square. This is what to do. Very important. We what to do? We rationalize. Into d means differentiate, upon d means what? Integrate. This is the complete theory. Repeat the theory, watch it again and understand how it works. If you understand this theory completely, you will 100% solve any problem given a particular integral. This is my method, this is my way. You will not find it in any textbooks or in VTU. So please understand it. If you follow this, then you can solve each and every problem perfectly. So please do that. Now before going to the solving the problems on particular integral, please I request you to go back and watch this video once, then we will solve the problems. Now as you have clearly understood how the type 2 particular integral method works, let us solve some problems to make it 100% perfect. Let us go a problem like say y double dash minus 4y dash plus 13y equals say take it as cos 2x. Okay. Let us solve this problem. Fine. So the first step what we do in the problem is what? Finding the complementary factor, right? So we write y double dash is what? D square minus 4d plus 13 into y equals cos of 2x. Then to find the complementary factor, we write the auxiliary equation as write d as m. This step remains same for all the problems, is equal to 0. Now we need to find the roots m, and for that we will be using the calculator. So as we are using here the Casio 9927W, we go to on home, then equation, we go to polynomial and it's ax squared by bx plus c. Put the values of a, b, c here. Is 1, execute, minus 4, execute, 13, execute. So we have x1 as 2 plus 3i and x2 as 2 minus 3i. So we have it as 2 plus or minus 3i. Okay, so m is equal to 2 plus or minus 3i. That means the complementary factor can be easily written as c1 cos of 3x plus c2 sine of 3x, sine and cos for the imaginary term, and for the real it's e raised to 2x. This is my complementary factor. Fine. I hope you got it now. This is very easy. Now next is finding the particular integral. If you see the right hand side, it's cos 2x. That means if you write here, see d square minus 4d plus 13 into y is equal to cos 2x. That means the particular integral solution is y2 is equal to cos of 2x whole divided by its d square minus 4d plus 13. See, we have in the RHS and the numerator cos ax upon f of t, sin ax upon cos sin ax or cos ax upon f of d is type number 2. That is particular integral type number 2. Okay, so let's solve this in the method I shown you. Okay, let's see. Please pay attention here. So I mean to say you take your pen, your paper or books and practice along with me, and remember the methods, the tools and methods which I share with you here. Following this, many students have followed this method and they have benefited from this scoring excellent marks. So now it's your turn. So please do as I say and practice along with me. So we have yp is equal to cos 2x by d square minus 4d plus 30. Fine. Now as it is type number 2, what to do? Remember, listen carefully. In type number 2, if the numerator sin or cos x upon f of d, replace only d square by minus a square. What is a here? See here, cos 2x, cos x is 2. Replace d square by minus a square, minus 2 square. It is minus, I write here if you want, replace d square by minus 2 square. That is, replace d square by what? Minus 4. Okay, repeat d square by minus a square, 2 square minus 4. Getting it? Since a is 2 here. Now let's replace. What is replace means? Simple English language. And one more important point, replace in the denominator only d square by minus a square. Don't touch the d's. Be careful about it. Here is where student get confused. They'll write d square is equal to minus 4, they take minus 2 and they'll do everything wrong. Don't do that. Here you are following me to get the complete marks. Okay. Now yp is equal to, we have cos 2x whole divided by, in place of d square put minus 4. See how I am writing it clearly, minus 4 minus 4d plus 13. Fine. That means this will be now cos of 2x divided by, always try to take the positive terms first. So we have 13 minus 4 is what? 9 minus 4d. This is what we got. Cos 2x upon whole divided by 9 minus 4d. Now again that implies, as I have discussed this in the theory already, if the denominator is simple upon d, integrate. What is upon d plus something or d minus something? We rationalize. That means we have this as cos 2. That means in type number 2 the compulsory condition is denominator should have a d square term. It should have compulsorily a d square term. Yes, cos 2x by 9 minus 4d. So what is the rationalizing factor of 9 minus 4d? Obviously it is 9 plus 4d. It is a basic thing everyone need to know, 9 plus 4d. If it was 9 plus 4d, the rationalizing factor is 9 minus 40 by 9 minus 40. It remains same. Now when I rationalize, we get this as 9 into cos of 2x plus 4 into d cos of 2x whole divided by 81 minus 16 d square. See here, I got in the denominator d square. Again do what? What to do in type number 2? Simple. Replace d square by minus a square. That's it. Only d square by minus a square. So minus 4. That's it. Now let's see the numerator here. So this is 9 cos 2x. Now again one more thing. In any solving of any differential equation, I kept on repeating this. Okay. Into d means what? Differentiation. Into capital D means differentiate. That's all. Into d, 4 into d. So plus I write everything step by step, 4 into d cos 2x means d means what? Differentiate. D means here in numerator d means what? D by dx. Differentiate. What d means? D by dx. That's it. That means d into cos 2x means differentiation of cos 2x. What if cos x? Minus sin x. Cos 2x, it is minus sin 2x into 2. So minus 2 sin 2x. Getting it? It means this whole d into we what? Differentiate. Okay. Upon 81 minus 16 into what? D square minus 4. Let's again simplify this. So we have 9 cos of 2x minus 8 sin of 2x whole divided by 16 4s are 4 6 are 24 64. It's 145. Let's again simplify this now. If let's simplify this, this will be divided by 145. I don't think I can. Okay, no, I can. So we leave it here only. Therefore, this is my particular integral yp. So solution is what? Y is equal to CF plus the particular integral pi. Fine. It means this will be now how much? So, this will be now, write the entire solution, adds the pi to CF. We have CF as C1 cos of 3x plus C2 sin of 3x whole into e raised to 2x plus, what's this pi? It's 9 cos 2x minus 8 sin 2x upon 145. This is my answer. Okay, I hope you clearly understood how to find a solution. That's it. Let's solve one more problem here to make it more perfect. So, let's think a problem as say, let's say d square y by dx square plus 3 dy by dx plus 2y equals, I take this as say 4, I take a different question, let's say 4 cos square x is a problem here. Interesting problem. See, you can frame thousands, hundreds and thousands, millions of problems in this, okay. But if you know the concept clearly, you can solve any one of them. That's it. Let's solve this a little different. I had not given cos, I given cos square here. Okay. So tell me what. So first, as usual, target on finding the complementary factor. So we have this as d square plus 3d plus 2 into y is equal to 4 cos square x. Okay. So I think it is a very simple factorization and finding the roots are very easy here. You may all know this, m is equal to minus 1 comma minus 2. Roots are really distinct. So the CF will be also very easy. So the complementary factor will be C1 e raised to minus x plus C2 e raised to minus 2x. Right? Fine. Now let's underline this. Now see, next thing is yp, the particular integral. So we have yp from here, the question, see, d square plus 3d plus 2 into y is equal to 4 cos square x. So yp is equal to 4 cos square x whole divided by d square plus 3d plus 2. Again mistype. It's not type number 1 and all, it can be type number 2, but again it's not type number 2. Why? Because this cos square. It's what? Cos square. Again go back, I had given each and everything. Whenever in engineering mathematics and solving question you have cos square, you have to use the trigonometrical relation or the identity. Cos square x is equal to 1 plus cos 2x by 2. Again listen carefully, this thing should enter your brain perfectly. What's cos square? Cos square is equal to 1 plus cos 2x by 2. Sin square 1 minus cos 2x by 2. I given everything. So that means they are given 4 cos square. See, if it is only sin ax or cos, if it was only cos x, then repeat this square by cos 1x minus 1. But it's not, it's cos square. So it's not 100% type 2. To make it type 2, you have to use the identity. As identity, cos square x is equal to 1 plus cos 2x by 2. Please listen here, be attentive here and practice with me. If you don't practice, you will again forget. Okay. So what we do? Again, we have 4 into what is cos square x? 1 plus cos of 2x whole divided by 2 into d square plus 3d plus 2. This is what we have. Okay. Now 2 1s are 2 2s are. Again we have this, we simplify this to yp is equal to, open the bracket, 2 plus 2 cos of 2x whole divided by d square plus 3d plus 2. Fine. Now again one more thing, while solving problems I already discussed that if the right hand side has plus or minus signs not standard, again separate it. Plus or minus is separate. Each part will have its individual particular integral. Okay. This is plus sign here, so separate. So we have 2 divided by d square plus 3d plus 2 plus 2 cos 2x whole divided by d square plus 3d plus 2. Fine. Now if you see carefully here, which are the types here? Here constant means type number 1. We can write here as into e raised to 0x. It means e raised to ax by f of d. We already learned. Watch the previous video. Okay, you'll get it if you haven't. E raised to ax upon f of d, replace d by a, all the d's by a. So what is a here? 0. So a is what here? 0 in this case. See, we get one type 1. So replace d by what? 0. Fine. We replace in denominator all the d's by 0. Fine. Right neatly. Fine. Here 2 cos 2x, plain cos 2x upon d square plus 3d plus 2 is type number 2. Particular integral of the type number 2 which you are doing here. That means in type number 2, sin x or cos x, what is here? Is 2 here. Is 2 here. Okay. We replace what? Only d square in denominator by minus a square. So minus of 2 square is 4. That's it. Okay. Now let's write it here. So yp equals 2 upon 0 plus 0 plus 2. So that is 2 plus. This will be when you replace d square by minus a square cos 2x whole divided by minus 4 plus 3d plus 2. Minus 4 plus 3d plus 2. Now 2 in the 2, 1 plus 2 cos 2x whole divided by, again as I told you, take always the positive terms first. We have 3d minus 2. Okay, we have till here. Again the things repeat. The denominator, numerator is sin or cos and denominator is d plus or d minus. So what we do? We rationalize, because compulsory condition again in type number 2 the denominator should have a d square term compulsory. So again rationalize. So this will be 3d plus 2 whole divided by 3d plus 2. Rationalizing factor of 3d minus 2 is 3d plus 2 by 3d plus 2. This two things same cancel, but when I multiply the denominator I get a form a square minus b square. That is the advantage of rationalization, because in type 2 we need to compulsory have the denominator as d square term. So 1 plus, for this now again open the bracket, 3d into 2 cos 2x plus 2 to the 4, right, 4 cos of 2x whole divided by, this is 9d square minus 4. Perfect. Again what we do? Replace d square by minus 4. Fine. This is what we get. Okay. Now let's follow this. So we have 1 plus, again see 3d into d 3 into, I write directly here, 3 into d into 2 cos 2x. Again into d means what? Numerator, into d means differentiate. Into d means differentiate, right? So this will be differentiation of cos 2x is minus 2 sin 2x, 2 to the 4. So minus 4 sin 2x plus 4 cos 2x whole divided by 9 into minus 4 minus 4. Fine. Done. Correct. Getting, if d is a numerator, we differentiate. Again 3d as 3 as it is, d of, see d of cos 2x, 2 cos 2x, 2 into differentiation of cos 2x again is, differentiation of cos 2x is minus 2 sin 2x. So this 2 and 2 gets becomes minus 4, so minus 4 sin 2x. That's it. I hope you understood now. Now all the d's are eliminated, so we have the solution. Let's simplify this. So we have yp is equal to 1 plus minus 12. So minus 12 sin 2x plus 4 cos of 2x whole divided by minus 9 4 that 36. Minus 36 minus 4 is minus 40. Done. So let's further simplify it here now. Basically simplification. So we have particular integral is equal to yp is equal to 1. So very simple division. Minus, I did not show this too, but still see. Minus 12 by minus 40, minus minus plus 12 by 40. 4 3s are 12 and 4 10s are 40. So, we get 3 sine 2x, 3 by 10 sine 2x, am I right? 4 3s are 12, 4 10s are 40, and this will be plus by minus is minus. So, we should be dividing 4 cos 2x by minus 40, that is it. 4 by minus 40 is 4 ones are 4 10s are. So, minus 1 by 10 cos of 2x. This is my particular integral. So, let us complete the solution here by writing y is equal to CF plus pi. We have CF as e raised to minus x plus C2 e raised to minus 2x plus 1 plus 3 by 10 sine 2x minus 1 by 10 cos of 2x. That's it. That's the solution. Beautiful. This is how we solve the type 2 and get the solution. See here, instead of cos square they can use sin square. As you know, sin square is 1 minus cos 2x by 2. They can use cos a into cos b or cos 2x into cos 3x. Then it is the formula cos a into cos b is half cos a plus b plus cos a minus b. They can give sin a into cos b. Correct. So, that means what? Whatever they give of this forms, apart from plain sine or cos, if they give anything like cos square, sin square, sine, cos and all, we have to use the identities which I have told you in the theory. I hope you understood how to get a solution. Okay, but practice is the main key. Done. So, my dear friends, that is all for today. I hope you clearly understood the method and how to solve the type 2 problems, and I am sure you won't do any mistakes here. So, if you have any problems which you want me to solve in upcoming videos, then please drop in the comment below. If you like the way I teach and enjoy my teaching, then please share these videos with your friends and classmates as much as possible. Like the video and please don't forget to subscribe. Please once again watch the video repeatedly and practice all the problems. Keep learning, keep improving, keep practicing. See you in the next video. Bye.